Now, let's take a look at more function calls. Okay? In our main function, we have to call my function one time, my function second time. Okay? Dot dot means other code. Okay, other code, I don't care. Therefore, in assembly, this dot dot correspond to segment number 1 here. So BL, my function, will jump to this part, my function. Okay, and execute something, and finally return. See here? Return to the next instruction next to my function here. Okay? Oops, sorry. Return somewhere here. This is my function number 1. Okay, so return to somewhere here and execute in the segment number 2, and then BL my function again and execute, return to this location, which is here, and then execute, and finally BXLR here, return 0. Okay? So you call the same function twice. This is what's happening. Okay? In assembly. And if you see the details, LR and the second LR store different locations. Different location. The first LR store the address of the first instruction of segment number 2. The second LR store the address of the first instruction of segment number 3. Okay, segment number 2 versus segment number 3, they are at different locations. Are we clear about function call? Okay, and for function call in lab 9, we are going to do function call in lab 9 again. How do we do? How do we do in standard? This is the standard way to handle function call. We use this part. We are going to use stack. In other words, this one is called stack segment. Okay? Stack segment grows downwards. You know? Downwards. Oops, sorry. Stack segment grows downwards. Okay? This way. And the first location of stack is the address, right? Look at this as a floor number, right? The floor number. So the address is stored inside SP. What is SP? Stack pointer. Okay, stack pointer, which is R13. R13 here is stack pointer. So the stack pointer will point to the first location of stack segment and then change in this direction, downwards. Okay? How to make changes to the SP? We use this instruction, push instruction. What does it mean, push instruction? We push the register values onto the stack segment. Okay, and you will see many examples of push in Lab 9. Okay, and how to grow back. We use another instruction, pop. Pop will change the address of SP, will change the value of SP up and up. Okay? Up and up. SP, stack pointer. Change the value of SP by adding more and more numbers. Okay? To change, to grow upwards. Pop, make the SP up or higher. Push will make SP lower. Okay? Push make SP lower. Pop make SP higher. Clear? This is the standard way to handle function calls. Okay? To handle function calls. And many programming languages follow this. Okay? Follow this. And what's next? Therefore, within the function, you can use R0 to R12 only. You can use R0 to R12 only. You cannot use R13 and R14 and R15. Are we clear? Because they store important addresses. Okay? Okay. Step by step. Step by step. I will explain push and pop in Lab 9 again. Okay? Because this is the lecture part. I cannot mess up the lecture. And function call can be handled this way. And you can see if your segment, your stack segment collides, you know this word, collides with the heap segment, it can happen, okay? Two segments can collide to each other, and this gonna cause the what we call exception. Okay, this is another technical term that you need to know. Exception. Handled by, if the exception happens, it's going to be handled by the operating system. Okay? What other exception that operating system needs to know? If you recall, divide by 0. Okay? 1 over 0 is one exception. Divide by 0. This is another exception. Okay? That's all for